Hi guys, in this section we're working on chord properties. So over here I have some self-check questions I'm going to go through. And then over here is the notes from 1.4. So I like to refer back and forth with those. So let's see what we're looking at. The measure of SQR. So SQR, that means this angle is 80. And then the arc, SR, which is labeled theta, is 106. So we want to calculate this arc over here. Okay, so there's a theorem to help us with this in the notes. I think it is theorem right here, theorem 64. So the measure of an angle formed by two intersecting chords is half the sum of the measure of the arcs intercepted by the angle. So to put that into terms of what we're looking at, I have the measure of SQR, that's what we're given, that equals half of the measure of arc, SR. So we would put M for measure, arc, SR. That's what's happening over here. Plus the measure of arc, TN. So if I take half the arc lengths, I'm going to get one of those angles. Okay, so now we need to label what we know. We know that the measure of this is 80. And we know the arc of SR is 106. And we're trying to figure out the measure of arc TN. So this is now an equation that we're trying to solve. So I'm going to distribute that 1/2 and solve for M of TN, which if you don't want to write that every time, just call this X. It's the unknown. It's what we're trying to find. So 1/2 times 106 is 53. And then I'm just going to say 1/2 X. That's our unknown. It's the arc we're trying to solve for. Okay, so now it's just a simple equation. Minus 53, minus 53. That becomes 23 equals 1/2 X. I'm going to divide both sides by 1/2. I just realized I messed up. That should be a 27. 10 minus 3, 7. 7 minus 5, 2. Okay, so X, or our arc length, is 27 divided by 1/2. Which is the same thing as timesing by 2. So 54. So that means this arc length is 54 degrees. Right there. Alright, let's look at another one. So now we have a trapezoid inscribed in a circle. And we know the measure of GC is 43. All right, and we're trying to find the measure of F to D. So right here. So there's a couple things that we need to pay attention to. We have a right triangle here. And this is a right triangle. And we probably forgot some facts about trapezoids. So see how these sides are the same? This means this is an isosceles trapezoid. So just like isosceles circles, the angles are the same. So this angle would be the same as this angle. and this angle would be the same as this angle, meaning that these right triangles are similar. These side lengths are the same, these side lengths are the same. So if this arc length is 43, this arc length would be 43 as well. So we just have a lot of symmetry going on because of that trapezoid. So now I want you to notice that we have a diameter here. That means that this whole side of this circle, the arc length, would be 180 degrees. It's half of the circle. So we want to subtract the 43 that we have, just because we want this section without the 43. So 180 minus 43 is 137. So this arc length would be 137. And if I add those together, the 137 and the 43, I would get the 180, which is half. But we're just looking for FD. Alright, so we have another trapezoid. It's isosceles because these are equal on this side, so that tells us a lot about our angles. So let's look at what we're given. G to J to I. So this is 82. And we want to calculate the arc of G, J, I. So through J to I. Alright. So we're not going through the center, so this line is not a diameter. It's not 180. We're going to have to figure it out. Alright. So let's see what we're looking at here. Because this is isosceles, this angle would also be 82. And then in our last section, I have those pulled up too. In our last section, this is from 1.3, we talked about quadrilaterals. So the opposite angles are supplementary. So that means the opposite angle of a quadrilateral adds to 180. So if I take 180 minus the 82 we were given, and I go across the quadrilateral, this will be 98, and this will be 98. So now I know all my angles, so now I need to figure out how to get some arc lengths here. So, let's see. I have this, and this will help me figure out the arc length from here to here, or that gives me some I don't need. So I'm going to look at another one. I know this to this is 98 degrees, the angle, and that also gives me that full arc length that I'm looking for. So again, we have to use stuff we've learned before. I'm going back to 1.3, and I'm looking at inscribed angles. So here I have an inscribed angle of 98 degrees. So what happens is the arc length doubles from the inscribed angle. We're not coming from the radius, we're coming from the triangle. We're making two chords. So if I take 98 plus 98, or 98 times 2, I'm going to get 196. So since this angle is 98, this arc length will be double that, which is 196. Okay, so technically on this problem, we really had to use 1.3 material, so we can't forget that stuff. Okay, now we're looking at sides. So use KJ. Let's see, K to J is 29. K to O is 34. L to O, so our whole diameter is 60. I'm just going to throw that out here. So all the way across is 60. And we're trying to find H. Okay. That's for X. That's around that. Hint. Find a way to apply Theorem 65. So I'm going to go back to my notes. So you guys can't see that when you get there. Look at, I just have different tabs open. This is 1.3, this is 1.4. Here's my calculator. Okay, so it's okay to just open up as many canvas tabs as you need to go back. So I'm in 1.4 and it tells me to use Theorem 65. So that's this one. So when two chords of a circle intersect, the products equal each other. Okay. Let's see. So here's our two chords. 29 times X. Those are intersecting. And our other two intersecting are the 34 and then this one that we don't know the length of. But we're going to use the diameter over here. So if I know this is 34, I can find the length of the other one by taking 60 minus 34. So 60 minus 34 is 26. So actually LM right here would be 26 because those two would need to add up to be 60. Okay, so 34 times 26. And now we're going to solve. So calculator, 34 times 26 is 884. So to solve for that, I would divide by 29. To get my answer. So round your answer to the nearest hundredth if necessary. So you would type in 30.48. Okay. So I'm doing a lot of examples on these because I know there's a lot of different types of problems. So again, we have an isosceles trapezoid. So those are equal, that makes it isosceles. We're given arc DG. It's 42. And we want to calculate arc FC. Oh, we've already done one just like this, so I'm going to go pretty quick. So remember, all the way around, since this is a diameter, all the way around would be 180. Well, all the way around would be 360. Half is 180. And because this is isosceles, it makes these triangles similar. So this would also be 42. So to find FC, I would take 180 minus 42, which is 38. So So you just type in 38. The degrees right here, so you don't have to type that in. Alright, measure of JM, arc JM, is 84 degrees. And the measure of arc KL is 66. We want to find K and L. So we want to which, let's just add, these are vertical angles, meaning they're congruent, they're the same. But I know there's a theorem on that, and it's this one, where we know our intersecting chords. So what we do here is we would take the measure of the angle. So let's do measure of angle KNL equals, and I'm just copying this part. It's half of the arc lengths. So it'd be 66 plus 84. So the measure of our angle is half. Let's do 66 plus 84 is 150. And we're going to take half of that to get 75. So 150, half of that is 75. And that is the measure of our angle. So this would be 75. This would also be 75. So you would just type it. So again, we have another trapezoid. This time we're given LM. We're given this tiny piece. It's 4. HI. It's 22. And we want to calculate the diameter. So I'm trying to figure out what the diameter is from here to here. The top part. Okay? So again, we really are using the property of this being an isosceles triangle that we're going to split this 22 in half because each side is equal. So instead of 22, I'm going to label these 11 and 11. And then we're going to use that Theorem 65, which I went past, where we multiply the chords. So right here, the chords intersecting are the diameter, well, it's actually this 4, and then this unknown, which we're going to call x, and then the 11 and 11. So the two chords there are 11 and 11. Equals the two chords here are 4 and x. So 11 times 11 is 121. To find the x length, we're going to divide both sides by 4. So 121 divided by 4 is 30.25. So what we just found out is we already knew that we had a little section of 4. We just found out the rest that we're calling x is 30.25. So in order to find the full diameter, we're going to take that 30.25 and add the 4 that we already knew. So it's 34.25. That would be the full diameter. Sorry guys, this is a long one, but I wanted to do all 10 problems. So we have a trapezoid. We know arc GC is 34. wait, that's GD. GD is 34, but this is also 34 because these are similar triangles, which we've gone over. And we want to find arc CF. So this problem we do a couple times. We take 180 because that's half the circle, and we minus 34. So that would be 146. And you would type that in. Yeah. Alright, so another trapezoid in a circle. If the measure of arc HI is 87, and the measure of arc HG is 75, calculate HKI. We're calculating this angle right here. Alright. So we can use inscribed angles a little bit here. So if this is 75, then remember this angle down here is half. So 75 divided by 2. So this would be 37.5. Or I could take from here to this chord to this chord. Let's do the full one. I know that this whole arc is 75 plus 87. So that's 162. So the angle would be half of that. So this whole angle would be 81. Okay. So the little angle would be 43.5 right here. To see if I can use triangles to figure out what that will be, because I know a triangle adds to 180. So now if I can get this angle, we can figure that out. So if this is 81, this is 81, we know that the opposite of these have to add to 180. So 180 minus 81 is 99. These two big angles are 99. But I'm wondering if we can get those split in half somehow. Let's see. Let's use our arc lengths that we have here. So that's 75. These are congruent because of this, right? This would be 75. That would be 37.5, 43.5. I'm just labeling everything I know, guys. Okay, so now I'm gonna look at this triangle right here, where I know two of the angles. I'm just going to redraw it out here. I know this is 43.5, and this is 99, and those have to add to 180. I'm going to take 180 minus 99 minus 43.5. So this is also 37.5, and that gives me enough. Now I can figure out this triangle. So I have a right triangle there, right here. where I could figure out half of that angle. So I have a right triangle, that's 90, that's 37.5, and they have to add to 180. So 180 minus 90 minus 37.5. So this angle's 52.5. So that means over here would be 52.5 because that's cut in half. So in order to find the full angle here, I'm going to take 52.5 plus 52.5, which is 105. So that one takes a lot of work, and notice that I just start labeling stuff I know. It's kind of messy, but you're going to just start to get enough information that you can just keep labeling everything. Okay? And there's lots of different ways to go at this problem, but there's one way. Okay, so let's go to the next one. Now we don't have a trapezoid, we have a kite inscribed in a circle, and we're given arc length 70 from CB, and notice that we have the same thing. We have same sides here. So I'm gonna just label that as 70 as well, because those are the same, they're both right angles. We want to calculate the angle measure, angle of C to D to B. So this one. Alright, so again, if we go back, I think it's even 1.2. I don't even think I have the notes up. I have two chords here. This makes a right angle. That's 90 degrees. Right? So that's good to know, but also I can use my inscribed angle here. See how these two lines make up that 70-degree arc? That means the angle is half of 70. So it's 35. That one actually used